Welcome back to Mr. DuPage's classroom. Today's lesson is for my CP Algebra 1 class. It is about section 2.6, which is probability. The first thing we're going to do is a review, so please take some time. Go ahead and pause the video and see how you can do on finding the mean, median, and mode of that data set. So go ahead and pause the video now. And let's see how you did. First off, the mean is going to be the average. So if we add up all those numbers, we'll end up with 405. There are 9 total numbers, so the mean would be 45. The mode, we're looking for the numbers that occur the most. If we look up top, 43 happens twice. That's the only one that happens more than once. So my mode would be 43. Finally, the median, we need to put them in order first. So it would be 23, 28, 40, 43, 43, 55, 56, 57, and 60. Go ahead and cross off first and last until we get to the absolute center, which is 43. Hopefully you did well on that. That was a lesson from not too long ago. Now we have some vocabulary. The probability of an event, or the P of event, is the likelihood an event will happen. Likelihood an event will happen. Flipping a coin and getting heads has a probability of 1/2. It's a 50-50 chance. Okay? An outcome is a possible result. Possible result of a single event. An example of that would be tails is one outcome of flipping a coin. The sample space is the set of all possible results. A set is just a data set, so a group of numbers in most cases. Results are also known as outcomes. An example of that, the sample space for flipping a coin is I could get heads or I could get tails. An event is a specific outcome. So an event in a heads or tails would be I got a heads or I got a tails. Those are both events. This could be a single outcome or a group of outcomes. Okay. All right, let's move on to theoretical probability. Theoretical probability is the probability of something happening on paper. So flipping a coin is a 50-50 chance. However, if you flipped a coin 100 times, it is very unlikely that you would get 50 heads and 50 tails. That is your theoretical probability that it is a 1/2 chance. So the theoretical probability is the probability of an event, P of event, that it's the number of outcomes we are looking for divided by the sample space. If you don't remember what sample space is, look at the vocab above. So let's go ahead and fill out this table. Rolling an even number on a die. So a die is dice. Yes, it's a single dice. The sample space. What are all the sides numbered? Well, they're numbered 1, 2, 3, 4, 5, 6. The favorable outcome is any even number. So our data set would be 2, 4, and 6. So how many favorable outcomes are there? There are 1, 2, 3. So it would be 3 divided by 1, 2, 3, 4, 5, 6. 3 over 6 is 1/2. So the probability of rolling an even number would be 1/2. How about flipping a coin and getting a tail? Well, the sample space would be heads or tails. The favorable outcomes would just be getting a tails. That would be 1 over 2. So it would be a 1/2 chance. Getting a multiple of 3 from the numbers 1 through 10. A multiple of 3 is anything that I can multiply to get 3. So 3, 6, 9, 12, those are all multiples of 3. The numbers 1 through 10, we need to write down 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That will be our sample space, all the possibilities of the numbers 1 through 10. The multiples of 3 would be 3, 6, and 9. So there are 3 possible answers, 3 possible good outcomes that we're looking for. How many numbers are there total? Well, there are 10, so it would be 3 over 10. It would be a 3/10 probability, I'm sorry. All right, probability. This is probability on a number line. On the far left here, we have a 0% chance. In the middle, we have a 50% chance. And at the end on the right, we have 100% chance. So an impossible event would be an event can't happen. An event that seems to be impossible to me is if it's 110 degrees out, you're going to see snow. That shouldn't be possible. I'm not going to say it's 100% impossible, but I'm guessing that it's not very likely, which I would give a 0% chance probability. A certain event, this is an event that must happen. It must happen. A certain event that will occur at this point is, well, right now I'd say seeing the sun, unless some catastrophic event happens that is unforeseen at this point. I would say seeing the sun again is an event that must occur. All right, let's look at the back. The complement of an event. The complement of an event would be the probability probability an event won't happen. So that is the complement or the opposite of probability. The way to write that is 1 minus probability of an event, or P of event. P of event, again, means probability of an event happening. You could see that on the front when we were talking about that. A bowl contains 12 slips of paper, each with a different name of the month. Find the probability that a slip chosen at random has a month that starts with J. What are the months that start with J? Well, we have January, we have June, and we have July. So there are 3 months that start with the letter J. So 3 is our favorable outcome over. How many total months are there? There are 12. So that would be a 1 over 4 probability. Number 2, it has a month that starts with M. What are the months that start with M? March and May. So there are 2 favorable outcomes over 12 months, which means it has a 1 over 6 probability. Number 3 has a month with 31 days. What are our months with 31 days? Well, we have January, March, May, July, August, October, and December. The months that have 31 days, there are 7 of them. There are 12 total months, so it is 7 over 12 probability. Make sure we're boxing our answers. I'm sorry, I forgot. Make sure we're boxing our answers. What is the complement of number 1 happening? So 4 works with 1. What is the probability or the complement in words? What does that mean? Well, what is the probability that the month does not start with the letter J? Well, if the probability is 1 over 4, this would be 1 minus 1 over 4, which would end up being 3 over 4. Okay? What is the complement of number 2? Number 5 works with number 2. In words, that would be a month does not start with the letter M. In this case, the months that start with the letter M has a 1/6 probability, so it would be 1 minus 1 over 6, which would actually be 5 over 6. So the probability that it would not be a month that starts with M would be 5 over 6. Now, experimental probability, this is actually what occurs. This is actually what would happen if I flipped a coin 100 times. That would be experimental probability. So it would be the number of favorable outcomes, or what we're looking for, number of outcomes of what we're looking for, over the number of trials, or the number of times, say I flipped a coin, the number of times I spun a spinner. Okay, that would be the number of times the trials occur. Okay, so for the next example, let's refer to the spinner below. I have already spun the spinner 20 times. After I spun the spinner 20 times, this is my results. It landed on 1, 2, 3, 4, 5, and 6 that many times. So the questions are over on the right. For the probability that it landed on 1 or 4, that is the question. The probability that it landed on 1 or 4. Well, we know for theoretical probability, it's just going to be 2, because there are 2 possible outcomes, or 2 good outcomes, I should say, over 6 possible outcomes, which would be 1 over 3. Remember, theoretical is what should happen on paper, just like you would have a 50-50 chance of flipping a heads or a tails. That is theoretical. Experimental, the trial occurred 20 times. I spun the spinner 20 times. How many times did I land on 1? I landed on 1 3 times. So I'm going to take 3 and add the number of times I landed on 4, which is 1. So it would be 4 over 20. 4 over 20 would simplify to 1 over 5. Okay? So all you're going to do is you're going to take the outcomes that are favorable, or the outcomes that I'm looking for, and we are going to put that over the total number of times that we tried something. Go ahead and finish this table. Pause the video, try to finish the table on your own. Once you are done, go ahead and restart the video and see how you did. Number 7 is the probability that the area is not shaded. Well, I only have 2 and 4 that are shaded, so that's going to be 4 out of 6, which is really 2 out of 3. The experimental probability, I can either add up all of the occurrences in 1, 3, 5, and 6, or I could take 1 minus how many times it landed on 2 and 4 over 20. I'm going to add up everything and divide it by 20. If you add everything up, it will end up being 14 over the number of times that we did the trial was 20. That can simplify to 7 over 10. Okay. Number 8, the probability of landing on 7. Is there a 7 on that spinner? No, so it would be 0 over 6, or just 0, and it would be 0 over 20, which would be 0. That would be a probability of an event that cannot occur, just like on the front, it was asking about that just a minute ago. The probability that n is greater than 2, well, that would be everything that is greater than 2, 3 through 6. The theoretical probability, or on paper, there are 1, 2, 3, 4 possible answers over 6, which is, again, 2/3. Make sure we're boxing those answers too, please. I know it's going to get a little tight when we're doing this, but you need to box answers. The experimental probability is, I'm going to add up all these numbers and put that over 20, which is the number of trials I had. So that would be 12 over 20, which would end up being 3 over 5. 3 over 5. Probability not 3. Here is where I'm going to use the complement when I get to experimental probability. But theoretical probability, if it is not 3, well, there's only one possibility of it being 3. So that would be 5 out of 6, right? Because 1 minus 1 over 6 would be 5 over 6. The experimental probability, the number of occurrences that happen with 3. I'm actually going to use the complement here. So it would be 1 minus 4 over 20. Well, 1 can be 20 over 20, right? So what's 20 minus 4? Well, that would be 16. So 16 over 20. 16 over 20 can simplify to 4 over 5. 4 over 5. And then finally, the probability that it will land on an integer. Landing on an integer, 1 through 6 are all integers. So that would be 6 out of 6, or 100%. And that would be 20 out of 20, which is also 100%, or 1. Okay? If you have questions on that, make sure you ask when you see me. More experimental examples. Quality control inspected 500 belts at random. They found no defects in 485 belts. What is the probability that a belt selected at random will pass quality control, which means it will not have defects? Well, that would be the probability that we will pass. So it will be the number of belts that were found with no defects, 485, over the number of belts that there were total, which is 500. If I take 485 divided by 500, I'll end up with 0.97. What is 0.97 as a percentage? It would be 97%. So the probability that the belt will not have a defect is 97%, which, if you ask me, is pretty good. Now, looking at example 13, if the belt manufacturer produces 6,258 belts, predict how many belts are likely to have no defects. Well, from what we just found out from example 12, when they pulled 500 belts at random, they found out that 97% of them were good. So instead of pulling all 6,258 belts and checking them one by one, what this company would probably do is take the 6,258 and multiply that by the 97% and find out what their probability would be. It would be that 6,070.26 belts were going to be good, which is about 6,070 belts that would come out with no defects. That has been your lesson on probability. Make sure that you look over the vocabulary once again. Realize that theoretical probability is the probability on paper, and that experimental probability is what actually occurs, and you should be good with this lesson. Thank you very much for watching, and have a great day.